triangles. That this is an absolutely terrible word. Don't worry about it. It's not important at this stage. What is important that you realise what it's talking about. It's talking about, here we go, a triangle where all the sides are different length. Okay, here we go. Look, internet's a wonderful thing, isn't it? That's describing it for you. It's amazing what you can find on the internet. When I was at school, you didn't have internet at all, and it made life less easy. Now, I would strongly recommend, if you've not watched it before, that you look at this particular video here. It demonstrates the area of a triangle. The equation for it is correct. It does it visually. Visit this one here if you've not done so far. Now, to prove that the equation is correct for this, I'd have to go into algebra, and it would get, for some, a little bit complex. So I don't want to go there. I just want to demonstrate that it is correct. The general principle, if you have, say, an area, yeah, look, I'm going to do a diagram here, and that is meant to be a straight line, and it wasn't. Try again, and yeah, here we go. Suppose we have a triangle like that, scalene triangle, right, where all the sides are unequal length. Now, if I was to do a dotted line and project that down here, now if I was to consider that as the whole triangle, which it isn't, you know, it's the artificial one, and subtract from it that area there, I end up with this area here. That is what we're going to be doing. So we're going to be working out the area of two triangles, the whole thing and this little bit here, right? That is the method we're going to be using. Right, let's set up the example. So we can, hang on, come on, give me a straight line, thank you. No, I'm not going to do it too large. I'm going to make it like that. No, I'm not. No, I'm not. I'm going to make it more obvious. I'm not going to do it like that. I'm going to do it like this. That's a bit better. Okay, let's try that colour there, shall we? Yes, we'll do that. Right. Project a line down there such that that angle there is 90 degrees. Now we've got to get some sizes to this thing. We need that, and we need that. We want that, don't we? So we in fact need that as well. Let's make that one there not very well presented. I should have drawn it bigger, but never mind. 3. That one there, 5. That way we have a nice number when we add them together. So of course 5 plus 3 is 8. So this dimension here will be 8. Now we need a height. We need a height. So let's give it a height. What shall we go for? Let's go for 10. Makes the numbers easier, doesn't it? Hang on, let's get rid of that. Okay, now we have, let me draw it again, and I'm going to put numbers or letters on it. So we end up with A, B, C, D. So that point there is D. That length is AD. That length there is AC. That length there is AB. That length there is BD. You see the way that works? Okay then, now we're going to give, so we want the area of the whole, which is triangle A, B, D. Triangle A, B, D. So we end up with, over here, we end up with, this one is 8, that one is 10, and yeah, that's all we need. Area of the whole thing, that is A, B, D, so obviously it includes the base, it's half the base times the height, right? The equation is half base times height. Look at the previous video, it demonstrates that that is indeed the case. So what we end up with here, half the base is 4 times 10, which equals 40 square units. So the whole thing is 4 times 10, which equals 40 units square. That is from there to there to there and back again. That's the whole thing. Now we want the area of this part here, which is CBD. Right, so area of the whole we've done. Now we want the area of BCD. Let's do that in that order. Area of triangle BCD. Half the base times the height. The base is 3, so half of the base is 1.5, or if you like 1.5. If it's 3, half the base is 1.5 or 1.5 times the height times 10. You can see now why I picked on 10. Well, that's 1.5 times 10 is 15 units square. So what we do now, we have the whole triangle, which is triangle A, B, D, the whole thing, like that, okay, is equal to 40 minus the little bit of triangle there, which is BCD, triangle BCD. That's what this is saying. It's saying the whole thing, subtract from that the little bit there. So we end up with, the whole thing is 40, subtract from that the little bit, which is 15, and that will give me, that's 20, at least 20, 25 units square. I know I'm labelling it like that. Labouring is what I meant to say. I know I'm labouring this point, but it's important. Okay, so the green area by difference, this is called, is 25 square units. Does the formula, when I apply it, give the same answer? Looking at the green, we have, for the green, alright, I'll put for the green triangle, which in fact is triangle ABC, right? ABC, so it's this bit here, is equal to half the base times the height. Let's see if we get the same answer, shall we? So we end up with half the base there is 5, so half the base is 2.5. Times the height, which is 10. Now 2.5 is 2.5. Times 10 is 25. Look at that. it is demonstrated that it works, right? This is not a proof. You'd have to prove that it works in every single case, no matter what the shape. This demonstrates that it does work. So now your mind can say to yourself, yes, I accept that. It works. I just need to use the formulae and work my way through the question. I accept that it works. It's fine.